This code stock presentation is brought to you by Telerik. Download trial versions of all of the Telerik controls and productivity tools at telerik.com. You can also visit us on Facebook at facebook.com/Telerik.
So part of this paradigm shift is that you have to experiment. You have to figure out where your boundaries lie. So when DOS was around, people started experimenting with using assembler for initializing different graphics modes and doing get and put pixels, and they went outside of just read and write lines, and they were able to create, whether it be menu systems like this or by using like ANSI.sys or just various ways of creating a better user experience to kind of differentiate themselves from their competition. The same happened when we moved to Windows Forms. Everything looks like some big gray Battleship that is very boring, and everyone using the same menus and same controls, and so people start figuring out how can I make myself different, be it a splash screen or better icons in their toolbars, or maybe some owner-drawed user controls that were custom that you couldn't find in other applications. Now that we're in XAML and we're dealing with WPF and Silverlight, now's the time to figure out where are the boundaries for WPF and Silverlight. I personally think that finding those boundaries is a lot more difficult. I think it was really obvious looking at DOS and looking at Windows Forms, now looking back at them, what their limitations were. But dealing with Silverlight and WPF has opened up a lot of new doors, and figuring out where the line is drawn for what is and isn't possible is something that people are trying to figure out right now. Another part of this paradigm shift that is different from previous is that now designers are going to be getting into the development of these user interfaces. So part of using Blend and part of moving into WPF and Silverlight is figuring out that designer and developer workflow. For some people, the designer-developer workflow may be as simple as you have a designer that lays out your user interface and does it all in Photoshop or an Illustrator and then hands you a full-scale comp. And then your designer-developer workflow is you get a picture and then you create it yourself. That's one type of designer-developer workflow. Another type at the opposite extreme is you manage to find someone who knows Blend, which is pretty difficult right now, and they're able to take the comps from one designer and actually bring all that into XAML and make assets that you can make use of. But figuring out how you're going to work with the designer is something that you now have to factor in. And from my perspective, that's kind of a one-off. You're really going to have to see what fits into your organization. We're lucky enough to have Flash developers or Flash designers where I'm at who were willing to learn Blend. So for quite a while, they were creating all our XAML assets, and that took the pressure off of me as a developer to have to know how to do that or to do it myself. Since that time, we've picked up more projects, so now I'm just getting full-scale comps, and I'm creating all the XAML in Blend. So figuring out that workflow is going to be important. And the final point on this is that this paradigm shift will start from developers. There are not designers out there that are just randomly deciding, hey, I want to learn Blend. People out there that are learning Blend right now are doing so because they're working with people doing Silverlight, and maybe they're in Flash or maybe they're in Photoshop or whatever they're used to, and they're willing to work with that developer to try and take some load off of them in the organization. So part of that point is that it's important for us as developers to understand enough of the designer mentality, enough of the designer tool set that we can help facilitate the introduction of designers into this new way of creating user interfaces in Blend. A lot of this talk is slide heavy in the beginning. At the end, it gets into concrete examples, but at the beginning, we're just going to cover a lot of smaller basics about XAML-based technologies for those that may not have dug down into it a lot more than just playing around in Blend. The focus of this talk is really how developers, how they play a role in creating these modern user interfaces. So the basis of all XAML, all user controls, is the UI element. So all these controls you see on the left that you might use in Blend, be it a text box, a button, a chart, progress bar, all of these things are derived from a base class of UI element. Just like every object you create in Visual Studio is derived from an object, right? So what that means is all of these things are actually UI elements, and as part of that, it means they all share common properties. So all of these things have opacity, and that's provided by the UI element class. Whenever you apply an effect to a control, you can apply an effect to any control because it's actually applying the effect property as at the UI element base class level. One thing that this facilitates is it makes it makes it easier for you to manipulate these things programmatically because they're all derived from the same class. So if, let's say, you are tasked with writing some piece of code that fades something in or out or whatever the case may be, you don't have to write a class called fade in and out text box. You write something called fade in and out UI element, and then you can reuse that code no matter what the UI element is. Another thing to keep in mind is that in this talk, everything we do will be at the UI element level, but sometimes there'll be a point in which you'll need to use a framework element, which is actually one step right above the UI element. So it takes the UI element and adds on more things like a tag, which I'm sure most of y'all are familiar with from Windows Forms controls. It adds things like actual height, actual width. The binding properties are all at the framework element level. So right above UI element is framework element. And sometimes programmatically you may need to work at that level. It just depends on if you need to make use of that tag property or whatnot. Typically you'll want to write your code against the lowest level you can just so you get more reuse out of it. The other thing that helps make up user interfaces is in XAML is our containers. And containers are things like the grid, the canvas, the stack panel. These are all things you put UI elements into to help your layout. You can see on the left here, this is the visual tree. This screenshot is actually from Silverlight SPI that lets you browse through the visual tree. You'll see something similar in Blend. Whenever you look in the bottom right-hand corner of Blend, you'll see here, this is, again, a breakdown of your controls. You've got your grid here, and inside of it has UI elements. One thing to keep in mind about panels are that they are themselves a UI element. It's still just a UI element. The difference is that it provides a .children's property, which is a collection of UI elements. So you can see any of these here that show something inside of it, grid, border, all these things are types of panels, and they have a collection of UI elements. It's UI elements collection. One of the things that having these types of panels and containers does is it makes it easier to manipulate your elements. So say you have 100 elements on the screen and you need to animate them. You don't want to animate 100 different elements. You want to put them all in a container or one of these panels, a canvas or a grid, and then just manipulate that one item so that if you go from having 100 items to 101, you don't have to change your code because you're acting on the highest level that you can act against that still changes what you're trying to change. And finally, another really nice thing about panels is it helps you make relationships between items. So whenever you have, let's say you have a grid and it has 2 buttons in it, you can ask for that button's position relative to its parent. So if you have 2 buttons that are on opposite sides of the screen, you can find out the position of that button relative to its parent for both of them, and then use that information to figure out their relationship between one another so that you could figure out the middle point and maybe put another button in between them. So panels help you figure out relationships between other children that are a part of the same panel. And another thing that you get through panels are these things called attached properties. So if you take a button and you put it in a grid, you're going to get attached properties like grid.row, so you can assign that button is in row 2 of this grid. That isn't a property that's a part of a button. It is an attached property it is getting from being inside of a grid. One caveat to that is this canvas.zindex. Z-index, is front to back, as far as the positioning of what order things are rendered. The Z-index is technically canvas.zindex, but you can actually make use of that property for any container. So if you have 5 objects inside of a grid, you can adjust the canvas.zindex, even though it's in a grid, and affect what order the items are drawn or how they're stacked on top of each other. but technically it's still an attached property. So now that we've got the basics down, we're going to get into basic concepts, and then we'll get into examples right after that. So a real basic concept that you have to understand when you're working with XAML or in Blend is this idea of a render transform. Anytime you hear people doing cool effects that they're doing programmatically, it's almost always going to be done with a render transform. What a render transform does is it lets you alter the appearance of a UI element. So you can change its offset, like you'll see here in this picture. We're offsetting to the upper right. You can change its rotation, like you see here. We're not showing skew, but basically you're able to alter the appearance of a UI element. The main caveat here being that this is a render transform, not a layout transform. So whenever you have XAML that's being rendered, it's going through two passes. It goes through a layout pass where it lays out everything relative to one another, and then it goes through a render pass. And the render pass is when it actually draws it to the screen. So these are called render transforms because they don't affect the layout. These changes that you make to the rotation and position don't occur during the layout pass. They occur during the render pass. So, for example, if you had 5 buttons in a stack panel that are all stacked side by side, you offsetting the position of one to the left 10 pixels is not going to make the others move or be affected because it's occurring in the render pass, not the layout pass. That said, there is something called a layout transform that is in WPF and not in Silverlight, but you can get it from the Silverlight toolkit. And in that case, if you did a layout transform, then it would affect other things because it occurs in the layout pass and not the rendering pass. So keep in mind, as part of that, is that all the changes you make in a render transform are relative to the current state. So if you do a render transform on an object, let's say that makes it 1.5 times larger, and it's originally 100 pixels, then when that render transform occurs, it's going to be 150 by 150, right? 1.5 times 100. But if you then go and let's say you physically alter the width and height of your UI element to be 200, that render transform is on top of what its actual dimensions are. So now that it's 200, it's 200 times 1.5. So now you're at 300. So these render transforms are after the layout. So it's always a relative change based on where it really is. So just to make sure everyone is on the same page here, I'm just going to show you in Blend here. I've got this grid, and I'm just going to add a stack panel. I'm going to make it take up the whole area. We're going to add a few buttons. I'm going to make them 100 by 100 just to make them easier to see. So if we copy this button, and then we go to the button in the middle, down here at the bottom, one of the properties is transform, this area here. And you see it has rotate, scale, skew, all the things I was saying are part of a render transform. So here we can scale this box, and we'll make it 1.5 by 1.5. And you'll see a few things. You'll see that it's not pushing the other items, even though this is in a stack panel, but it's also underneath the third button, which goes back to my point about the Z index, or the order in which things are rendered from bottom to top. If this were WPF and not Silverlight, you would actually be able to not make use of this render transform here, and you would be able to make it where it was a layout transform, in which case it actually would push the button below it further down. Any questions so far? Everyone tracking? So the next concept I want to talk about, or really the first concept that's not straight out of the box, is layering. If you've done any work with Photoshop or Illustrator or anything like that, you're probably familiar that you add a layer and you draw on it, you add a layer, you draw on it, and you can reorder these layers. Whenever you're working in Blend, there's no such thing as a layer per se, but by using panels, you can kind of simulate layers. So like I was saying earlier, all panels have canvas.z index, so you can adjust the order in which these layers occur. In effect, I want this drawn, and then this, and stack them. So by stacking panels, you can facilitate depth. You'll see here in the lower left is a picture of Street Fighter, which is probably 15 years old now. But the reason I have that up there is at IQ, whenever we can't figure out how to do something and we're trying to hash out how are we going to accomplish something, sometimes we'll say, well, we'll just do like the Street Fighter style. And what we mean by that is that rather than try and create this effect on one flat sheet of paper, we're going to layer things, stack them on top of each other so that we can do things you wouldn't otherwise be able to do. So in Street Fighter, you have this background where the plane is. That's one layer. On top of that, you have these people who are also in the background, but they move. And that's a layer on top of it, so that when his arm moves, there's not a hole behind it. You can still see the layer behind it of the plane. On top of that, you have the two players. On top of that, you have the projectiles. On top of that, you have the status bars at the top of that. And on top of that, you have a menu system that's currently hidden. Another thing to keep in mind when we talk about layering is that there's no reason at all why you can't have a button, and once you put it on a grid and blend, later come and remove it from that grid and put it on some other grid. There's nothing that says once a UI element is placed somewhere that it has to always stay there. So you're able to remove an element like a button. You can remove a button from a layer and then add it to another layer, and then you can move it back to the other layer, whatever you want to do. But there's no reason. Go ahead.
Can you do that same technique programmatically?
Yeah, and that's actually what we'll be doing here in a little bit. Everything I'm going to be talking about is all programmatic. So, another nice thing you get from layering is that you can develop relationships based on common container. So, in this example here, the common container for all these layers is this 300 or 320 by 240 rectangle. So here where this character is, he may be on a character layer, but his position means the exact same thing as the position on the projectile layer, on the background layer, on the menu layer. His position is his position across all layers because they all share this same shared relationship, this same shared screen size and positioning. So keeping that in mind, we were talking about earlier, you can build relationships between elements inside of the same container. You can build relationships and understanding of positioning not only inside the same container, but across multiple containers, assuming that they all share the same common container, or they're all laid out in the same position. So you can kind of see here in this stacked up thing here. First off, has anyone here used Prism, also known as Composite Application Guide? Okay. So Prism is this guidance that's put out by the patterns and practices at Microsoft, and their example is a stock trader, and it has a header area and a footer area and a sidebar and a main area. The idea with Prism, one of the ideas is composite UI. So you declare these regions and you can put things into these regions. And I got a chance to talk with them recently, and they were asking me how I was using it, what I wasn't using, that kind of thing. And I told them that their composite UI for regions and declaring regions and putting things into them was cool, but that I hardly ever use it in a way like that, like header and footer and sidebar, but that I stack them on top of each other and use them like layers. And so here, it's probably pretty hard to see, but in the very back there's a blue background layer, and then right above that is a sidebar here, and a header here, and a footer, and a main area. And you can see I'm stacking layers on top of these. So this main area here, you can barely see, has 3 layers stacked on top of that. Also, I have these 3 layers that are stacked over the whole thing. And so if I have something in the background and something here in this foreground block, I can figure out where their positions are relative to one another because they're the same size in the same place. And we'll see why that's useful here in a minute. Now that we're through those basics, we're going to get into examples. So we did a Silverlight Firestarter in Atlanta. It's probably been a year ago now. And I was working with one of our designers at IQ, and we were presenting on doing animations inside of Blend. And we were discussing how typically you want to do all your animations in Blend, but we brought up that you can also do all your animations in code if you wanted to. And I wanted to make sure people understood that sometimes you cannot do animation inside of Blend. Even if you want to, you may have to do it in code. And so this was an example to prove why that was the case. So here we've got two list boxes, and the idea is we just want to let users, maybe the left is want and the right is do not want, and we want them to select an item and move it to the left, or select an item, move it to the right. I'm sure you all know exactly how you would do this programmatically. Whenever someone clicks on left, you would get the selected item from the right, you would remove it from the list box, and then you would add it over there. So it would disappear here and it would reappear there. And my point was during our talk at the Firestarter that you could animate that between the two, but you could not do that in Blend. And the reason being is that these are dynamic items. So there could be 2 items in each list, there could be 100 items in each list. In Blend, at design time, you may not know how many items are there, so you can't design against that. So this would be a prime example of where you would programmatically want to animate an item between these 2 lists. So we're going to walk through how this is done. First off, I'm just going to run it so you can see what I'm talking about. So you select an item on the left and you hit the right button, it removes it and adds it to the other list. This is what we're all familiar with. What we're going to create is where you select an item from the list, you hit left, and it flies between the left and the right, so that the user doesn't see popping, as we call it, where something disappears and reappears. They actually see the item physically move. That font size good for everybody? So we've got 2 methods here. One is transition from list to list. The other one is transition from list to list. Hold on one second. Sorry. We've got one that's transition from list to list with no animatics, and we've got one that's transition from list to list with animatics. So I'm going to blow this one away because this is the one we're going to write. So you can see in our regular one, this is the way you would normally do it. You say it takes in the from list and the to list. So if they click on left, then the from list would be the one on the right, and the to list would be the one on the left. So it takes in 2 list boxes, knowing which one we're going from, which one we're going to. It gets the selected item from the from list, and if it gets back null, if it can't find the selected item, then we know they don't have anything selected, so we don't do anything and we return. The rest of it's pretty normal. You would remove the item from the from list, you would add the item to the to list, and then reselect the item in the new list so that their selection stays. So what I want to encourage is to challenge yourself to imagine how you would facilitate flying this list box item between the 2. So we're going to go through it in code, but I'm going to try and explain the concept first and then make sure we're all kosher on what the concept is. So as I was saying earlier, everything's a UI element, right? So this is a UI element, this is a UI element. This is a list box, and it's full of list box items, and list box items are UI elements as well. So what we can do is there's a method called transform to visual, which we'll do here in a minute, that lets you say what is the relative position of this UI element to some other UI element. So what we're going to do is we're going to say where's the position of this selected UI element to the upper left-hand corner of this of the bottommost root, also known as layout root. So that we'll figure out what this distance here is between these 2. Then we're going to actually go ahead and remove this item from this list and add it to that list. Once it's on this side, we'll do the exact same thing. We'll say, what is the position of this item now that's in this list? Imagine it's right here. Now that the item is here, what is its position from here to here? Okay, so we've got the X offset for this, we've got the X offset for that, and we also have the Y offsets for both as well. So if you take this X value and subtract this X value, you now have what that distance is on the X. And if you do the same for Y, then now you know what exactly the X and Y offset is from here to here. Okay? Everyone clear on that? All right? So all we're going to do is we're going to calculate that position here, put it over there, calculate that position there, and we're going to use the render transform, like we talked about earlier, where you can modify the position, how it appears, something appears, so that this item that's here, we're going to offset it that distance that we just calculated, so that it appears like it's still over here. So we're going to actually do the remove just like normal, do the add just like normal, but we're going to give it a render transform so that it still appears it's over here based off that calculation. All right? After that, we're going to do an animation on that render transform that will animate that render transform from, let's say it's -300 and -20 is the X and Y coordinates that we offset it to. We're going to animate that to 0, and that will make it animate to where it's supposed to go. Okay? Everyone clear on the basic concept? Yeah. So we're going to get started the same way. We're going to take this, let me hide this, try and give some more real estate. Okay, so we're going to start off the same way. We're going to get a handle on the selected item. If there's not one, we're going to return. The next thing we're going to do is we're going to figure out where is this item in its current list, okay? So like I said, there's a method called transform to visual on every UI element. And you'll see that it takes in, just the right, yeah. So this UI element takes in, okay, what element do you want this relative to? And we want it relative to the rootmost element on the page, which by default is always layout root. So you see here, layout root is, that's layover root. Layout root is the rootmost element of my user control. So we're going to say, I want to figure out where this list box item is relative to layout root. And you see that returns a general transform. Technically, what it really returns is a matrix transform, so you always have to cast it. Why it always returns general transform, I'm not sure. I've never ever seen it anything but a matrix transform, but general transform is the base class for a matrix transform. So we're going to cast this to a matrix transform. We're going to store that as the original position. Okay. So if you look on this matrix transform, you see that it has this matrix property, and that contains these offset values. Okay, so that tells us what the offset is between the list box item here and the layout root we compared it to. So this offset x is the distance between list box item and the layout root. Layout root is basically 0, 0 upper left. Or at least it will be, because that's what it will be by default. So what we want to do is we want to calculate, actually we're not going to calculate anything yet. So we stored off the position where it was originally. Now we're going to keep doing like we did earlier. We're going to remove it from the list box on the left. We're going to add it to the list box on the right. Then we're going to reselect it. And now we're going to do the exact same thing again. We're going to get its new position. We're going to say, okay, now that we moved you to where you're going, where are you at now? Okay. One caveat we need to do here is we need to force this list box item to update its layout. Basically, if we didn't do that, it wouldn't update its layout until the next layout pass occurred. But by doing update layout, we're going to force it, update your layout now, so that whenever we get its position now, it will be changed between where it was when we just had it before. So now we've got the new position and the original position. And we're just going to calculate the difference between the two. So all positioning is done in doubles. We're going to say, give me the old position, what do we call it? Original position, matrix dot offset x, and subtract the new position, matrix offset x, So that gives us the change in X. We're going to do the same thing, get the change in Y. No idea why my machine starts doing that when I use the screen recorder. So now we know the offset between those two list box items. So what we need to do now is go back to what the next step was, which is we know the difference. So now that it's in this new position, we need to set a render transform so it appears like it's still in the old position. So we're going to create a render transform and assign it to this list box item. So the list box item has a property called render transform, which you definitely need to get familiar with. And this has basically got all our properties on it that we were talking about earlier, where you can it can skew and things like that. But it's actually done by a transform group, and a transform group is made up of skewing and rotating and scaling. So I use this class that I've actually used in every Silverlight app I've done, basically to wrap around some of this code. So basically it's a method we're going to pass in an X and Y, and it's going to build us this transform group that we can assign for our render transform. And all it's doing is adding the scale, skew, rotate, and translate, and all it's doing is setting the X and Y value. So we're basically just creating a transform group to assign to this render transform. So I'm going to say listbox item dot render transform equals, I'm going to use my storyboard helper. We're going to get the offset, and we're going to pass in our offset X and our offset Y. So this just basically created a render transform for us with an offset of X and offset of Y that we just calculated. It's going to assign it against this listbox item. So technically now our listbox item is in the new listbox. It's on the right, but now we've assigned a render transform, so now it looks like it's never moved. It's still where it was. And it happens fast enough that the user never saw anything. So as far as they're concerned, it's still in the left list. But really, it's already in the right list. So it's kind of like magic in that sense. On the two list box?
When you move that, it's sitting on top of one that's moved up.
Correct. You are correct. Like if you move this one that we have selected, all the other ones bump up, right? So that's actually, if you wanted to take it one step further, and I was going to mention that later, you could figure out how to animate those to even slide up so they don't pop. But usually your eye is so caught by the thing moving that you wouldn't even notice that anyway. So now all we have to do is animate it. And I have, again, something that helps build storyboards. You can find tons of articles on the internet on how to build a story programmatically. It's not very fun, but it's very easy to wrap a storyboard in a helper method, which is what I'm going to make use of. So all my helper method takes in is it takes the item we want to animate, which is our listbox item, the point you want to go to, which, like I said earlier, we're going to animate to 0, 0, right? Because it's in the list box on the right. We're going to, or it's on the. It looks like it's on the left, and we're going to animate to where it really is. You got to give it a time span. And then it can take an easing function. It's kind of out of the scope of this, but an easing function. I'm trying to think of the easiest way I could illustrate it. An easing function is basically one of these. So you can do an easing function that during your animation it does it really fast and it slows down, or it starts really slow and speeds up, or does an elastic kind of bounce back and forth thing. So there's various easing functions. For now, just know that we're going to give it an easing function just so that it looks cooler than just animating between the two. So we're going to use an elastic ease and pass that into my method that's building our storyboard. And then all we have, go ahead.
The storyboard is essentially the animation timeline?
Yeah. So basically when you build a storyboard is made up of keyframes. And you're saying, like, at this point you're in this position, and then it's saying So it's animating wherever it currently is, that's frame 1. And then we passed in new 0.00 over here. So it's making a second keyframe with 00. And then it's taking the time span we pass in and building a storyboard of that time to go from X to Y. So then we do sb.begin, and we run. And so when we select one and hit right, it flies over to the right. So you can kind of see what's going on here. Now, I went through this because I was hoping it was simple enough to wrap your head around. But there's actually an issue with this that you would notice if it was running much slower. So I'm going to make it run much slower. This is an issue that's specific to us doing a list box manipulation. So we've got list box items that are inside of a list box. So if you take a list box item from here and render transform it so it appears over here, it's getting clipped by this box. So you actually won't see it over here. So now that I've slowed it down and we animate one of these, you'll see, not quite slow enough, but you may be able to see that it actually just totally disappears. Let me get rid of this easing so you can see it. So you see how as soon as I click right, it will disappear from the left. And you'll only see it really animate in the right. See what I'm saying? And the reason is because we're removing it from that left box and adding it to the right. And as soon as we do that, it's now being clipped by the right list box. So you no longer see it until it's inside of that right list box. So earlier we talked about layering things and using relative positioning between layers. So the solution for this is instead of just keeping everything on a flat plane, we pop this list box item up to a layer that's over the whole screen and put it on that and animate it so that it's not clipped by the list box item. The issue there being that a list box item inherits what it looks like based on what list box it's in. So if you take a list box item out of a list box, it goes from being a line like this to being this big old blob that fills, because the style of this is fill up as much space as you give me. And once you take it out of that list box, it's going to take up the whole screen. So what we're actually going to do is something with writable bitmaps. Writable bitmaps are something I've added in Silverlight 3. Basically, you can take any UI element and say, render an image that is of this UI element. So what we're going to do is we're going to take this list box item and we're going to render it to a bitmap. And then we're going to animate that bitmap across the top layer. And then once it's done, we're going to get rid of the bitmap so that it'll look like the item's moving, but really it's a rendering of that item. It's a picture of that item that's moving. And I've got a lot of other concepts I want to get into because, like I said, really the point of this is to try and wrap your head around larger, different concepts. So I'm just going to copy and paste this code, and then we'll just run through it and show you the main differences. So to start, I'm going to get rid of this easing again, and I'm going to slow it down so you can see that it really is not going to get clipped anymore. So you see it's moving over top of everything between the two. And it looks like a list box item, but really it's a bitmap. So if we look here in our code, it's very similar to what we just did. We get its initial position, which I'm now calling initial position relative to root. It's the same thing as it was when it was old position or original position. So we're getting its original position, we're removing it from the list box item, adding it to the new list box item, forcing it to update its layout, getting its new position, calculating the difference between the two. The difference comes here. We create a writable bitmap from our list box item that we're moving. We put that into an image. So we create this image, which is a UI element type, and we add this to our layover root. So if we look in Blend, you'll see on top of this stage, we have this thing called layover root over here. And this is a grid that has nothing in it that takes up this whole area here. So what we can do is we can add that bitmap we just generated, add it to that layover, and then do the same transition we're doing before. The only difference is when the animation completes, that's when we're going to remove it, or we're going to add it to the to list. So we'll remove it from one, animate, and then once the animation's done, we'll actually add it in the to list.
So are you adding it twice to get the first one to get the position?
Yeah, we add it to get the position, immediately remove it, do the animation, and once the animation's done, then we really add it. So let me change back what it was, and then this is kind of the final thing, and it's not getting clipped anymore. And like I said, if this weren't a list box, if these were just rectangles, then you wouldn't have to worry about clipping. You only have to worry about the clipping because it's a parent container for a list box element, and it clips all children all the time. Any questions on this concept before we move on to some other concepts? Exactly. So if you don't specify z-index, then by default, the further down the visual tree, the further closer to the user. All right. So let's go back to the deck here. This is a product we built for MSN, and depending on how time runs, I'd love to show you some other way more complicated stuff that we had to do. But I want to show again the layer parallaxing kind of effect. So these are basically widgets, and when you click on one, it grows to a larger size, and it pushes all your other widgets back and layers them out and puts this one up top. And the way this is done is with a layering effect. We have two layers here. We have a top level pop out layer, and then we have this one in the back where all the widgets are. So whenever we go from this here, when you click on one of these, we actually remove it from this layer, we put it on this new layer and animate it up to the large size, and we take the other layer that we were just dealing with and we angle it out and blur it out. So we're using two layers to simulate this kind of depth of field or parallaxing effect. Well, it's mostly depth of field. Great. Okay. So I'm going to go ahead and get into basic tips when you're doing this stuff, when you're trying to figure out how you're going to accomplish something that someone gave you that you haven't approached before. First off is build prototypes, build test beds, write unit tests. Whenever we wrote this MSN project, each of these things are different widgets. They're pluggable widgets that are downloaded and showed to the user at runtime. Rather than have to run this application and log in every time we wanted to test out a widget, we created a widget test harness that lets us put a widget in it and immediately test it out without having to log in, without having to go through all these other steps. So when you're trying to build something programmatic, build it in a test bed. Don't build it where it takes you 20 seconds or 40 seconds or 5 minutes to get to the point in the app where you can see it. Avoid depending on specific UI element names. If you're animating something and you're doing 100 manipulations against text box 1, don't rely on it being named text box 1. Wrap it in a property and animate against that property so that if your designer goes and renames it to text box 22, it doesn't break all your code. When possible, manipulate containers and not elements. If you have 100 elements, don't manipulate 100 elements. Put them in a container, manipulate the container if possible. Always disconnect event handlers from dynamic elements. If you're doing things programmatically where you new up something at runtime and attach a click event handler and then remove it from your stage, if you didn't disconnect that mouse click event, it'll never get cleaned up. So always make sure you disconnect your event handlers for anything you programmatically create. Obviously, if it's being created by Blend, then it's going to handle all that for you. Just general to programmers, don't exaggerate your animations. Most animations should be like 200 milliseconds, 300 milliseconds, no more than that. Only use programmatic UI manipulations when you need to. There's more of this you can do in Blend, the easier it'll be to fix, update, maintain later. I'm only suggesting that you need to know programmatic manipulations when when that's the only way to accomplish it. Another knows Silverlight Spy. Anyone in here familiar with Silverlight Spy? It basically allows you at runtime to look at the state of things. And I hadn't really planned on going into this, but since so many people haven't seen it, if you're going to get into Silverlight, you have to know Silverlight Spy. All it lets you do is take your website, any website, and actually this is really fun for Silverlight apps you find online. There was a T-Mobile Silverlight app this week that was an anagram, and every day it would reveal a piece of the anagram, and it was written in Silverlight. So you could just pop it open in Silverlight and in Silverlight Spy, and you can change the values of your UI elements on the website. So I could just hide all the blocks and see what the anagram was 30 days before you would otherwise. So like you could see, you can select any, this is your visual tree over here, you can select any item in it and you can change properties of it. So I can make this have 0 opacity. And you see now the header's gone. So whenever you can't figure out why is this anomaly occurring, Silverlight Spy is perfect for being able to drill in and examine the properties, figure out what change you can make in Silverlight Spy to fix it, and then go do it in Blend or in your code.
What is Silverlight Spy? Is that a third-party tool?
Yes. It's created by, his name's going to skip me now, he's a Silverlight MVP, and actually I think he provides free copies of Silverlight Spy to people who are Silverlight MVPs, and he otherwise sells it commercially, and I think we got a license for like $119, which honestly, like some of the bug fixing that we've done wouldn't have been feasible without it, so it's hard to put a value on it. Another tip, no link. I didn't really mention it earlier, but when we were talking about panels, how they have collections of UI elements, if you know link, you can write a query against that collection of items. So say you have a grid with 100 buttons in it, and you want to find the button that has a text label of OK. You can write a link query that says grid.children.where element such that element.text name equals OK, and you can use link queries to query against your panels. Silverlight is, a new technology. Link is relatively new. Lambdas are relatively new. But if you're doing WPF and Silverlight or any XAML-based UI, knowing Link and knowing Lambdas is very important, or you should learn them at the same time. The next thing is on performance, and I've got a quick demo I can run through to kind of show these concepts. Whenever you're doing all this stuff programmatically or you're trying to create something really cool visually, watch out for effects like blur and shadows. I'm not saying don't use them, but I'm saying that I've seen many instances where using a blur or a drop shadow incorrectly can cost you a 20-30% performance hit or higher. Know the difference between opacity and visibility. Opacity, you can make something have an opacity of 0, but it will still go through the layout pass, it'll still go through the render pass, so it's still being rendered even though you can't see it, whereas visibility, it's not going to be rendered. The main thing to keep in mind here as well is that you can animate opacity. You can animate from 100, totally visible, to 0 and have it fade out. Visibility, you're either visible or you're not, so you can't animate visibility. There is something called the visibility pattern, which kind of merges the two together and will allow you to fade out the opacity to 0, and then it will automatically make it visibly collapse so that you'll get the benefit of both being able to animate your opacity as well as not get the hit of rendering something you can't even see. There's frames per second counters in all these technologies. There's something called redraw regions that you can turn on, and it will show you what's being painted, so you can see maybe you have something that's being redrawn over and over and over again that's wasting your performance. There's GPU acceleration that you should definitely make use of. And now I'm just going to show you an example of the different type of performance you can get based on how you attack a problem and why it's so important to pay attention to performance. So the basic concept here is we hit go and it shows 1,000 dots on the screen. Let's say that you're going to build a particle system and your designer wants it where whenever the user moves their mouse, there's some particles flying around. So you could write a test bed like this that renders 1,000 items and figure out, okay, what kind of performance can we get out of this if we're using images, or if we're using drop shadows, or if we're using blurs. So, for example, here in the lower left, you should be able to see it says 66 frames per second. It's the same as this upper left number here, 69 frames per second. And I was mentioning earlier about how effects can have a big performance hit. So we're going to turn on blur. And I think I have some of my caching turned on. Let me turn that off real quick. I showed you the after instead of the before. Oops. So you can see by default, this thing runs at 3 frames a second whenever blur is turned on. And it's because we're not really optimizing this to account for that. So I mentioned earlier there's a thing called GPU acceleration, right? Where it'll use your graphics card. You can see that's actually turned on right now. But in all actuality, even though I have it turned on, it's not giving me any benefit at all. So there's another flag called enable cache visualization, which will, and what that actually means is when you use graphics acceleration, it's going to cache items as bitmaps. So it'll cache the way something looks as a bitmap until it changes. And so that way it stays pre-rendered in your video card and saves you some performance. So by turning on this enable cache visualization, it will color code the screen. Not doing it. Anyone see why that's not working, bunch? Is that it? Thank you. I'm about to freak out. All right. So now you can see when this runs, everything's red. And what that tells you is that not a single thing on the screen is being optimized. It's not using a graphics card at all. So to actually have something get cached or allow something to be cached, you have to create a bitmap cache object. It can be a static object. And then tell any UI element that its cache mode is to use that bitmap cache. So just this one little change here on these dots will make all of these dots be white now, which tells you that they are being cached. This is rendered once, cached in the graphics card, and then just moved around. It's not doing the layout in the rendering pass other than for positioning. It's not doing it for actually drawing the circle. So with that turned on, let's try it with the blur effect. And you can see now we're running at 67 frames a second. So it's night and day performance difference based on whether or not you are optimizing it to make use of these different things like GPU acceleration. One other side point, I'm going to turn this cache back off. Right now, I'm actually applying this effect to every single circle. So you see, this is called get element instance. I'm iterating 1 to 1,000 and calling this method, and it's giving me a circle. And I'm applying this effect at the circle level. So I'm applying 1,000 blur effects and 1,000 drop shadow effects. It would make a lot more sense to, instead of doing it at the child level, to do it at the container level. So here, after we iterate through our elements and add them all to our main container, we're going to put the effect at the container level, so it's only applied once instead of 1,000 times. Now I turned off the caching so that you could see that now that change will actually make where the blur, let's see. So you see the blur actually runs at 10 frames per second, 13 frames per second now, whereas earlier it was running at like 7 when we were doing it at the element level and we're using no caching. The gotcha here is that you can't do caching at the container level because things inside that container are changing. So you can turn on caching, but what's inside of it is changing every frame, so that cache is just getting thrown away every time. So it's useless. So while it may make sense to do the effect at the container level, which is what I've been preaching at the beginning, do everything at the container level, everything at the container level, the caching, you can't do it at the container level. You have to do it at the level where change doesn't occur anymore, which is at the element. Because once we draw the element once, that circle, we don't ever need to draw it again. We just need to move it around. So that's one caveat to the whole always do it at the container level. All right, I got 10 minutes left. I really wish I had more time, but to go back to the change in paradigm that we're in right now, doing things in XAML now, you have to be willing to reevaluate feasibility. There's things that used to be impossible when someone came to you and said, I want an item to fly from one list box to the other. That used to not really be feasible unless you want to do all sorts of hours and hours and hours and hours. Now it is feasible, but you have to get your mind thinking outside the box. Part of that is you need to allow more time to evaluate feasibility. A lot of times working on that MSM project, we had designers and user experience people coming to me and asking, we want to do this. And my gut instinct was, no, it's not possible. And then it would gradually eat through my brain, and then one day while I'm eating a sandwich, I'd say, it is possible. This is how we could do it. So you have to allow that time to explore and to figure out what is and isn't possible. So as part of this, I want to show you an example of evaluating feasibility. We recently went through a redo of our drawer in this application, and for now, just pretend like these both say page name. That's actually a typo. So they came to me and they said, we want to use an expander control. Everyone knows an expander. It's got a header. You click a button and it shows something else, right? So they're like, this is an expander. Just make it where when they click the button, it shows a text box. All you got to do is style an expander. And we were like, all right, cool. And this was just one thing in this entire drawer rework. So this was just like one task out of 100. And we didn't think much about it. We were like, yeah, we'll just style an expander and call it a day. This is not an expander control. Does anybody notice why it's not an expander control? The reason it's not an expander control is that an expander has a header. When you click a button, it expands out more. And this, when you expand it, this disappears, and then it adds something else. So it's not an expander that's having a header and a body. It's actually an expander that has like a phase 1 and a phase 2. So it's technically not an expander. And because we didn't notice this while we were evaluating feasibility, we reached the end of this project and we're like, what are we going to do? We can't just style this thing. What we ended up doing, just as a side note, is we bound the visibility of this to whether or not it was expanded or not, so that whenever it was expanded, it would be hidden, and when it was collapsed, it would be visible. But that was really a very lucky hack that worked well enough. Technically, it would pop a little bit because when you hide that label while it was expanding, it would immediately shrink smaller before it grew larger. And that pop, we could have gotten rid of it had we noticed this earlier, but last minute we had nothing we could do. Does anyone have any questions? Go ahead. Sure. This is my website, Smarty Pants Coding, and it's the same name of this talk. It was posted November of last year when I first wrote this code, and it's got all the code up there. I don't think that it factors in, though, for the issue where it gets clipped by the list box, and we did the writable bitmap. I actually never noticed that issue because it was such a fast transition, but whenever I was preparing for this talk, I noticed the issue, and that's when I moved to using the bitmap overlay on top of the whole thing. So this code doesn't have that. Any other questions? Go ahead.
Where's the stage?
Did I say stage at some point? Yeah? I call just the general area of the stage, and part of that is like if we look at this here, this area here is the stage. That's what we decided to name it because we couldn't come up with a better name. So I typically call like the main area of the app the stage. But no, it's just my terminology, I guess. All right, well, I guess that is it. Y'all enjoy the rest of CodeStock. Oh, I have a book to give away. Can anyone, and this is a book on WPF, which people diss WPF all day long, but I learned Silverlight from WPF, and I would still highly suggest learning WPF. Anyone tell me the difference between a UI element and a framework element?
Framework element is a level above you.
All right. There you go.
Thank you very much.
Oh, no
That
problem.
was really good. Just one of those things I've been trying to work through this stuff, and the idea of using the panels as layers overlay is something I hadn't really.
Yeah, when I talked to the Prism guy and told him we were doing that, he looked at me like, why would you do that? I was like, well, you try and figure out how you're going to do this and that.
And just these transitions, like inside two list boxes, exactly like you're doing.
Yeah.
It's like I was doing a thing that was just like a radial layout, right? And I was just using a canvas to do everything. And then you would add more items to the layout, and I wanted everything to shift over and get new things in. I was trying to do it with behaviors and things, and it's possible, but there aren't the events in Silverlight that you really need to. You want these things to fire off into the events.
Well, in
and you pretty
Silverlight-
much only get the layout changed again.
Yeah. Well, in Silverlight 4, there's a new thing in Silverlight 4 with list boxes and stuff where you
The
can.
pathless box.
Well, there's a path list box, but there's also like a way to hook into the transition so that you can hook into when an item is added. This is how it should animate in, and when an item is removed, this is how it should animate out.
Oh,
I can't remember the technical name for it. It was added in Silverlight 4, so
Oh, okay.
I haven't had a chance to use it, unfortunately.
One other question. You said use programmable transitions for animations only when you have to. Is that pretty much when you've got dynamic items?
Yeah,
That's your benchmark. If you're bound to a
exactly.
list of something, then you're going to have to do this by hand.
Exactly.
Okay, great. Thank you very much.
Great presentation. If I
Appreciate
go
it.
to your site and go to the content folder, I can find.
Yeah, you'll have to, if you just do a search probably just for the name of this talk, maybe, thinking outside the box. Nope, haven't reached that yet. But if you do a search for my website and thinking outside the box, then you'll find it. Or if you just go to my website and look through the history, you'll find it.
Okay.
So,
Thank you very much.
oh, no problem.
Thank you for watching this CodeStock presentation brought to you by Telerik. You can download trial versions of all of the Telerik components and productivity tools at Telerik.com. You can also follow us on Facebook at facebook.com/Telerik. If you're interested in learning more about MEF or Windows Phone 7 development, I encourage you to visit my blog at blogs.telerik.com/Robert Shoemate, where you can download session materials from CodeStock related to each of these subjects.